Alright, welcome back everyone to another video, and in this one I'll take a look at a GOTEK USB floppy disk emulator. And if you are anywhere in the retro scene, you would know what this is. And yeah, so this is a very famous replacement for existing floppy drives that have either died or that aren't needed anymore, because floppy disks, you can't really buy them as readily as you used to. But with older systems, Amiga, Ataris, and all that stuff, even some of the older IBM PC stuff, you still need the floppy drive to perform certain tasks, whereas earlier it wouldn't have been possible, and you would have to go for a new, like a floppy drive, and buy one and get into the whole business of buying floppies for it. Right, with this thing you can just plug in a USB drive, and you can just go ahead and select your floppy disk. The problem is, well, it's not that exciting just to you buy something and use it, so you have to modify it. And there's where the fun lies. Now this uses a 34 pin floppy disk connector, and that is different from IDE, which I learned. Now I know the once I have tried to connect it, it was physically difficult, impossible to connect it. But I earlier thought the floppies were on the same bus. So there's that. So the floppy connector is separate. This will replace your actual floppy drive on your system. There's multiple selections you can do to make it configurable with different kind of consoles or systems on PCs from back in the day, and we are going to modify it. So the first of all, what we are going to do is use a very famous thing called FlashFloppy, which is basically a modified firmware for the STM32 ARM processor in there. And you can modify it, and you can add much more functionality, a lot wider range of compatibility, and stuff like that. You can add a lot of peripherals to it, but we'll be adding just one today, which we'll be replacing the LED display here with the FND display here, the 7 segment one, with an OLED display. So I have the OLED display with me, and we are going to replace. What that helps us is we can now get file names on the display itself, whereas with this one you'll have to guess which file you're on according to the number it shows. And that is what I wanted to do. And of course we'll flash the open source firmware, and that's one of the major points I wanted to do. It is I have a choice to actually run an open source firmware on it, so I will. um, right, so we are going to go the flash floppy route. So first we are going to change the display. We are going to populate the programming header. It's not actually a programming, it's a programming header, but we are going to use it for boot selection. But we're not going to do the UART programming. We are actually going to do the DFU programming, which means we can just plug this USB port in to any of our system, use the DFU programmer, open source on Linux, and I think it's all available on macOS and Windows, and flash this thing with the latest binary image. Now there are a few models of these clones, so like clones of clones and stuff like that. Uh, but these go most famously by Casio or Yamaha keyboard synthesizer floppy disk replacements. Those synthesizers used to have, or keyboards have a floppy drive to get the MIDI files on and off the keyboard, and these are intended to be used as a replacements for those and configured in a way. So but of course you can use it with whatever you want. So you have those three screws, and it pulls apart like that. And you can see LCD or the FND display is on these four wires. We can just use these wires and connect our OLED display, and it will just fit right in. So which is the fun part. Of course we have the LED here. There was supposed to be a red LED, but I don't see it, but I see a red LED pinout. Is it? Or is it just green on this one? Might be just green on this one. And yeah, and this is our programming header. And this is a, let me see, this is a ARM STM32F105. So let's see if you can Google that. So a Cortex M3 with a maximum clock speed of 72 megahertz, and it's running at 8. It has a 8 megahertz clock source, but could be running at much more with PLL and stuff. Yeah. So OLED replacement first, and then we'll go for the header. And I'll just bring this one out for ease of use. This should just pop off. Nothing's glued, which is it looks like someone made this specially for hacking. I mean, this doesn't look very consumery. Like people were there and they were like, yeah, let's make something that people can easily hack on, and that's always appreciated. Like if you make something that can be easily hacked on. Yeah, we have the programming header. We have some more headers here. You can go nuts on this one. One more. So, amongst the mods that you can do, you can add a rotary encoder and stuff like that. In case you feel that the OLED display is too small, you can actually add one of these like LCD displays that have have I2C backpack on it, and they will also plug into the same interface, and you can configure it accordingly. But the problem with that is there's no place to actually hold it. It just becomes too large. So if you have a very custom setup, yeah, sure, you can add this, and this will give you a nice big display with two character rows. But I think the OLED should be fine. Anyways, the system that I'll be using is going to be tucked down somewhere. So we just remove this, and you know what? I can actually use this elsewhere if I need to as a module. This has a nice little what looks like a nice quick C driver. Could be something else entirely. TM1651 could be a different kind of a circuit. Not sure if it's I squared C. I don't want to bother looking into the data sheet right now. So the green one goes to SDA and the bottom one goes to SCL, to ground. Right, so our display is set up. Now we need to populate this header, and that would allow us to put the whole board into boot mode and do our DFU programming from there. So I have the soldering iron hot and ready. I have this set of pin that should fit right there, minus the one single pin that we need. So I'll have to cut this one off. So one thing that I didn't do was to ever test if this module actually works. So as far as I'm concerned, this module could just be dead, and I might as well just be wasting my time on it, and even make it unreturnable. But for what it's worth, we have this. So the mods are basically done. All we need to add is a jumper from here to here, and a jumper from this wire to this wire, I think. And that is on the website, how to do that. So I'll go and follow that. But right, hopefully this time the mod's done. So we place this back in the board, in the case, and there you go. It sits, it fits. Take this outside, keep it outside, leave it dangling for the time being, close everything up, and good as new. Yeah, more or less. Right. screw it back down. And we'll figure out what we do have to do with this later on, but for now let's see what jumper connections we have to make here and be done with that. Also, we need to configure jumpers for IBM PC. Let's see if it's pre-configured for that, but I don't think so it is. Let's configure that and make the other stuff. We need to short a pair of pins, which is this particular one and this particular one. So I'd go black and black, and then the one right next to it and the one diagonal from it. So just to show you guys what the configuration actually looks like, we have these two pins shorted out, the black and the black, so you can see right there, and then the white and the white, which is the diagonal pins, shorted out. And of course everything's on the wiki, I'm just showing you. And we have jumpers on J, C and S0. Rest everything else is open. Now while we are programming, the power can be fed through the USB port, and that is what we are doing. We need a A to A cable, which is easily you can find it online anywhere. And from now I'm just going to jump over to sharing the screen. I'll plug this in, show the D message log how it looks when it's plugged in, and update the firmware, and then we'll move on to actually installing it. Alright, so I have my type A to type A cable right there. I have the GOTEK module that we just modified right there, and I'll open up D message and show you guys how it looks like on Linux. Once it's plugged in, so it takes a bit of time. So you can see there's the whole reanimation thing. So I'll plug that in, and this will take a while for it to actually come up. Might just be my setup, but usually happens. And now, so it comes up as the device we want it to show up as. Now we can just go into and use DF utils. We have to download the package as well. So sudo dnf install df utils. And it's already installed. I'm just showing that what the command line is. Should be util or tools. We'll do a search if this run. Yeah, so dfu util package is already installed. So what we need to do is to download the FF GOTEK V 1.10. Second. So we have to download this file. So we'll go into the download section, download FlashFloppy, download the zip. So we'll just open with files, and we have our .dfu right there. Copy. So again, I'm doing the non-experimental stable version, and I know you guys can't see the file manager. The screen sharing is kind of weird. I have to correct that, but I've just copied the .dfu file in the folder, and I'm just copying it to the home directory for ease of use. Once that's done, we don't really need anything else. You can switch back over to the terminal, and there, and now we have to just follow a couple of commands, and that should be flashed. And the first one, we are going to do the unprotected one, because it might be factory blocked, and this should actually do that. And let's try without the unprotected one. I don't know if it should look like that. Yeah, now it's downloading onto our actual board. So let's see second element, and we should be done. So now if I remove the bootloader settings here, we should see the LCD come up. Also, we need a couple of things before the LCD come up. We have to configure our USB drive in order to have that happen. But I'll show you how that's done. So we remove that. We remove both the bootloader pins. Now, as far as I know, nothing should really happen, or it happens and it comes up. So there you can see it says, not sure if you can read it, says FlashFloppy version 2.13 on the OLED display. So it is working. We have flashed the FlashFloppy firmware on that using TFU. Now we'll go ahead, connect it onto our system and see it working. It might take a while for me to do that, so I'll just fast forward everything. Won't get deep into how to connect everything together. It depends on the case, it depends on so many things. I don't really want to get into it, but for now we have flashed it, it's working, and let's go and try it out. Right, so now everything is installed. Let's power it on, and you can see that it does show us our OpenBSD drive, and here it should now start booting from the first floppy, which it does did. So we are booting OpenBSD from FD0, and it should now boot into the installer. So as you can see, the read speeds, it does sync properly, so it is going to take a while. And I'll show you guys in the BIOS, and also actually going into the menus, to the boot menu, and seeing that this is actually booting from the floppy, but it's obvious from how slow it's booting that it is actually booting from my floppy. So let's wait. Right, so this will take a while. I will show you the boot menu or the settings. So you can see the first floppy, disklet A is 144 3.5, and boot is the first, default boot is the first floppy drive. So I can just exit and enter the boot menu, or it just starts to boot. So I wanted to show the boot menu, and there it is, loading the boot menu and first floppy drive, and then actually starts loading from the host floppy drive. Let's boot. So FD0A BSD, we are booting from the first floppy, and we can wait. And there we go. Now we are booting. Yeah, so it leaves us here, and if we start the installation shell, just go a little bit further, won't be installing. Is FXP? Oh, so it's not taking the wireless network card, so that's fine. FXP0 is probably the dial-up modem that we have there. Yeah. So yeah, that's all it. That's it. It's working on a Pentium 4, the 34-pin floppy drive header with the FlashFloppy firmware. Thank you so much for watching, and I will see you all in the next one. Make sure to subscribe and hit the bell icon if you like this video, and I will see you all later. Now, in case you're wondering what the Arduino LLC is, it's this little mouse I built, which I'll be doing a video on sometime soon. Bye.